Morning, everyone. Can you guys hear me? Just give me a thumbs up or if you can. Perfect. So today we are going to be doing SAT prep. I have to get all this stuff set up. So if you have your packet, please go ahead and grab your packet. Just give me one moment. I can post it later. So if you guys have problems or you get kicked out, you don't miss anything in between, okay? So back to the question. So age of boy in inches. What's happening? I can hear the lag in John's video. Okay, in terms of the boy's age, A. So we know that A is age. Okay. H is the height. Okay, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So we're not actually asking to solve what it is. It's somewhere in this model. Okay, do we kind of know what it would be? Does anyone want to take a guess? You guys can put it in the chat.
How do we know the finished height?
Well, we don't. We're not actually, it's not asking me to find out what the actual height is at one of those ages. It's just telling me from this model, there's an average amount of height that the child should be growing every year.
Well, I guess so he's like 28.6 inches to start with, I guess.
Yes.
And then would it be 28.6? I don't know.
No, you got right. So the 28.6 is a constant, right? There's no number next to it. There's no changing it. So this is what?
Would it be 28.6 times 3?
No, almost there. So this is the original height.
Oh, it would be 28.6 equals 3a?
Oh, that's the whole model. Wait, no, that would be, no. It's just from here. We don't have to do anything to the formula, to the equation.
Oh, okay.
We just have to look at it and see, okay, the height, we're not really looking for that. We're looking for the average amount he grows every year. Okay. So if we're looking for that, which one, what number?
A would be how much? No, that's his age. 3 times his age, 3?
3, right? So it's saying that for every year, he's gonna grow about 3 inches. Okay, so he's gonna go about 3 inches per age. The 28.6, right? When the kid goes to the when the kid goes into the doctor, right, the child doesn't start from 0 and just grow out of the ground like a beanstalk. Okay. Remember, guys, in your class, if your classmates are having issues, remember I'm recording this. So I'll post it up on my YouTube channel and I'll send out that link on Remind so you guys can join it and watch it later. But I record everything. Okay. And it's by period. So you watch the one that's for your period because, you know, you're at different spots. Okay. I know it's a weird situation right now, but it's only temporary and I will be back in the classroom as soon as possible. Okay. So we have the original height. The child doesn't grow like a beanstalk. It's not a plant. So they have to start somewhere. They're starting at 28.6 when they go to the doctor. Okay. Every year that passes, every age, he's going to grow about 3 inches, and that's going to be added to the base height. So this is my base height. Original height / base. It's the baseline. Okay. Questions on that one? So a lot of these questions in this no calculator portion are going to be pretty much look at this equation and figure out what the parts are for it. Okay, so if you figure out A is the age, which they told me, H is for height, all you need to know is what does the 3 mean and what's the 28.6. If the 28.6, whatever number is there, doesn't have a variable, it's a constant. Okay. So remember when we did that problem of the kid who was mowing the lawns and said he gets $25 a week and everything like that? That 25 was a constant. He always got 25. The child is always going to start at 28.6 inches. Okay. So you got to figure out if there's a letter next to it, it's going to be changing, right? And it makes sense. If the child goes in at 3 years old, 3 times 3 is 9 versus when he was 2, 3 times 2 is 6. So he's going to grow a little bit more the older he gets. Okay. Are there any questions on that one? We're good. Give me a thumbs up. I want to make sure. Perfect. Okay. Now the next one. Oh yeah, we have to skip number 7 because number 7 isn't very difficult, but it's a lot of steps. And I want to make sure that I can do it without having to stop and figure out what I'm doing. And it's easier, I think, if I already have it in mind so that you guys don't have to watch me try and figure it out. But it's not so bad. It really isn't. It's just moving things around. But again, I want to be able to have that one ready to go for you. So the number 8. Number 8 says A over B is equal to 2. What is the value of 4B over A? So what is B over A compared to A over B? What's the magical word?
-2.
No, not yet. What's the magical word I'm
half.
looking for?
Half.
No,
Inverse.
no, begins with an R. Go by.
Reciprocal.
Reciprocal, right? So A over B and B over A are reciprocals, right? Remember, the reciprocal is just when you flip the fraction upside down. So if every whole number is a fraction over 1, what's going to be the opposite of 2 over 1?
1/2 or 1 over 2.
1/2, 1 over 2, same thing, right? Now I can go ahead and just plug that in. So my B is 1, A is 2, 4 times 1 is? Guys,
4.
4 over 2. So 4 divided by 2?
2.
2. That is my final answer. Okay. That one was pretty simple. As long as you realize that it's the reciprocal and that 2 is a fraction over 1, you know that you just have to flip the numbers. And that goes for anything. If that was the number 4 or 5, it would still be 5 over 1. So B over A is 1/5 or 1/3 or whatever it is. Okay, and then you just plug it in and solve. All right. Now the next one. Okay, so I need us to pay attention to this next one because it's one we haven't done yet, but it's very important because we are going to do it. Okay, it's very, very common. I'm only going to show you one way right now, what I consider to be the easier way. And, you know, you guys ask me questions and we'll get through it. It's good though, because you already get to see this kind of problem before we actually start to solving. So this is solving a system of equations. Okay, when you're solving that, you're looking for an x and a y value, right? We have both of them here in the equation, but now I don't want to deal with more than one variable, right? Whenever we solve an equation, you always want to try and get only one variable, okay? So my first step, step one, align my variables. So the first thing is you want to make sure that your x's are on top of your x's and your y's are on top of your y's. So I don't have that here in the second one, so I need to rewrite it. My first equation can stay the same. My second one is where that switch is happening. So now it's going to be negative x plus 2y equals negative 19. So far, so good. All I did was rearrange that second equation so that I had all my x's together and all my y's together. Okay. Step two. So in this case, what we're going to do is we're going to solve it by elimination. So basically what we're looking for is subtracting or adding so that we can get rid of one of my variables, okay? Which variable is going to be easier to eliminate from our equations?
Y.
No. So if not y, then
X.
x. So the reason why x is better to do is because x, you already have a minus x. If we wanted to do y, I would have had to multiply by a negative, and it would have been a lot more work. When this case, I'm going to just multiply by 3 so that I can cancel. Okay, so step two is pick the variable and multiply to get the same value. It's a long step, but it's not really. Okay, so I need to multiply this bottom equation by what number again?
3.
3. So everything gets multiplied by 3. All right, so I keep my 3x plus 4y equals negative 23. And now I get negative 3x plus 2 times 3 is 6, y. And negative 19 times 3? You guys have your calculator.
Negative 57.
What is it?
Negative 57.
I forgot. Okay, so it is 57. Negative. Remember that the negative stays. So now I can go ahead and step 3, combine like terms. Okay, so 3 minus 3 is what?
0.
0. 4 plus 6?
10.
10. So 10y. And then negative 57 minus 23. Remember, that's just
Negative
same.
80.
That's the same as just doing 57 plus 23 and keeping that negative sign. Okay. Now what's my last step?
Divide by 10.
We're dividing by 10, which gives us y equals, what's negative 80 divided by 10?
-8.
Negative 8. Now, of course, the book only has one option with negative 8, but, and I'm just going to
We
tell
don't
you
need to
this
do any
now.
work.
Yeah, you don't have to do any more work, but I'm going to tell you now, we don't have to do it this time because they only gave one answer with negative 8 as y. But when we actually start doing solving systems of equations, what you do afterwards, and again, you don't have to worry too much about this, I'm just letting you know, because on my tests, you're not going to have only one option with negative 8, okay? So what you would do is you would take that negative 8, pick one of the two equations, and then replace y with negative 8 and solve for x that way. It's much faster once you get that first number, okay? Are there any questions on number 9?
Sorry, how did you say we were, sorry, so we choose one and we plug in the y to find the x?
So yeah, so in this case, we solved for y, so we're missing x. So I pick whichever equation I want, either equation number 1 or equation number 2, and I replace y with that negative 8 value. And then once I solve that, it'll give me what my x is. Just like a regular equation. Remember the first problem we did in this pack? Oh, you guys, probably weren't there. But the first problem in the packet, we were given an equation that had two variables, and they gave me k equals 3. And all we had to do was replace k with 3 and then solve, okay? So this is kind of the same thing once you get that y value or the x value, depending on which is easier, right? We all want easier math. Yes, I think we can all agree. So doing this and picking this, the easier variable to work with, is a big help, okay? Are there any questions on number 9? Like I said, this is something that we're going to do later on. There's like 3 or 4 different ways that you can solve for a system of equation, but I like this way the best. Elimination is my favorite. I think it's a much better way than the other ways, but that's just me. All right, number 10. So number 10 says g of x equals ax squared plus 24. All right, it says for the function g defined above, a is a constant and g of 4 is equal to 8. What is the value of g of negative 4? So this one we kind of have to think a little outside the box, okay? Because what do we need to find? We have too many variables. I need to figure out what a is. That's my first step, okay? Now they tell me when I have x equal 4, right? Because remember, when I have g of 4, this 4 goes where my x is. Okay, so that's telling me that my x values are being replaced by 4. So when x is equal to 4, this entire equation equals what number?
8.
When my x, it equals 8. So when my x equals 4, my entire equation equals 8. So I can write 8 equals a 4 squared plus 24. So far, so good? So now I just have to solve, right? So my first thing, remember my PEMDAS. I wish they let me pick more colors so I could have easier access. PEMDAS. First thing is my parentheses, and conveniently it is with an exponent, so that takes care of my first 2 letters. So 4 squared is what?
Wait.
4 squared, 4 times 4.
16.
16.
Yeah.
16.
Okay, that's what I said.
So 16a plus 24. Okay. Now, what's my next step after?
Subtract 24.
So now I want to move that 24 out of the way. Eight minus 24 is?
Negative 16.
Negative 16 equals 16a. What's my last step?
Divide both
A.
sides.
Divide both sides by 16. A equals what?
Negative 1.
Negative 1. Oh, I froze. Okay, I'm back. All right. Now what? We're not done, right? So now my whole goal was to find g of negative 4. That's what I'm looking for. But at least now I know what a is. So now I can go back. I go ahead and do g of negative 4 equals negative 1 times negative 4 squared plus 24. So now it's just our regular solving. So we already said negative 4 squared is equal to what?
Negative 16. No, 16.
Just
Plain
regular
16.
16. Remember that it's really negative 4 times negative 4, and two negatives equal positive. So that's a negative 1 times 16 plus 24. What happens to my 16 now?
Times negative 1.
So now it will become negative. Negative 16 plus 24 is equal to
8.
8. That is my final answer. So it was a little bit longer, right? This is more like how you would do a system of equation if they didn't give you that only one option, right? You would find one variable, plug it in to find the other value, okay? So any questions on number 10? It was 2 steps, but wasn't too bad. Okay. So the next one, number 11. So in the equations above, B and C represent the price per pound in dollars of beef and chicken respectively. So obviously B stands for beef, C is for chicken. X weeks after July 1st during last summer. So it says, it's basically telling me these are the prices so many weeks after July 1st last summer. Okay, what was the price per pound of beef when it was equal to the price per pound of chicken? Okay, so does anyone have any idea what we're doing here?
We're setting
Aligning.
What do you mean by aligning?
Putting the x values over the x values and the y's over the y's.
Ah, but I only have how many variables?
1. So
You set B and C equal to each other. You put,
Exactly.
Pick a
I'm
constant
looking-
and substitute it.
I'm looking for when both of them are equal. So what I'm going to do is I'm going to do 2.35 plus 0.25x equals 1.75 plus 0.40x. Okay. Now it's just the same thing I've been doing. Combine my like terms, solve for x. So what's the first thing I want to do?
By my terms. Move.
So I'm going to move something. I don't really care which one I move first. It doesn't matter. Both sides have to have something moved. So I'm going to start with the 1.75. And if you can, move the value so that you can stay on the positives, right? So 1.75 is the smaller number. So rather than moving 2.35, which would have given me a negative, I want to move 1.75 so that I stay in the positives. Remember, we want to keep it easier, right? So 2.35 minus 1.75 is equal to,
1.75.
but no,
Wait.
I did it in my calculator. It's 0.6. If you guys
Oh.
need a simple, oh no, you're not allowed to use a calculator. I can use a calculator, but you guys can't. But if you were to do the subtraction, that's 0, borrow from the 2, 13, 13 minus 7 is 6, 1 minus 1 is 0. So that's how we get that. I was gonna say, if you guys need a calculator, there's some in the box on my desk, but you can't. Not on this part, maybe in the next time. Okay, and that leaves me with my 0.40x on that side by itself. Okay, now I need to move that other x. So the opposite of 0.25 is negative 0.25. And once again, it's the smaller number, which works out very nicely for me because that eliminates all the negatives that I had. Okay, so 0.6 equals 0.40 minus 0.25 is what?
0.15.
Right? Because I have to borrow from here, that becomes 3. 10 minus 5 is 5. 3 minus 2 is 1, and 0 minus 0 is just 0. Okay, so it's 0.15x. And my last step,
Divide by 0.15.
I divide by 0.15.
How do we divide 0.6 by 0.15 without a calculator?
The old-fashioned way. The little house. we
How do
all
you do that
remember
again?
this?
No.
Okay. Oh my goodness. So first off, nothing's going to go into 0. I'm going to put my decimal there. 15 goes into 60. What?
I hate the
What?
house.
Why are we saying that?
It's
We don't hate.
0.0. It's 0.04, right?
Why?
Because 15 goes into 64 times.
Yes, it goes into 64 times. So it will be what?
0.04.
The other way you could have figured it out is just doing 60 divided by 15, right? And that would have given you 4. But then you could have just put in those zeros where you needed it. Okay, same thing, but it is 0.04. So x equals 0.04. Is that what it was asking? We don't have to plug anything else. No, we still have to plug in things. So now, which equation do we want to use? The beef or the chicken?
Beef.
Beef. So now what we have to do is replace that x. Okay, wait, I need a second sheet of paper. So now my x was equal to 0.04. Now I take my beef equation and I'm replacing x with 0.04. Okay, now I have to solve this. So now I have to do 2.35 plus, and then you have to do on the side your 0.25 times 0.04. Do we all know how to do that on the calculator? I mean, without a calculator? We remember?
No.
Oh my goodness. We're in bad shape. I'm gonna have to do some times table drills with you guys.
Is it 1?
Almost. So,
Is it 0.1?
no,
Oh,
almost. 5 times 4 is 20. 4 times 2 is 8. Plus 2 more is 10. Oh my gosh. 4 times 0 is 0 plus that 1. and I have to put in another 0. That's 5, or that's 0, 0, 0, 2 more zeros, and then 0, 0, 0. We all get what I had to do there, why I added so many zeros. Remember that every time I have another number, I have to add another 0. So 0, 0, 0, 0, 0, 0. And now I just like confused myself. So let me draw my lines. 0, 0, 1, 0, 0. Now who remembers how many times I have to move the decimal?
Doesn't it have something to do with like the number?
4 times, so it is 1. Oh no, it's 10. 4.
Wait,
Move it
how
4
do you
times
know it's
because
4?
Because there are 4 in the multiplication.
So there are 4 numbers after their decimals in the entire multiplication. So that means that I have to go 1, 1, 2, 3, 4. Do we see what happened, Leah? We were off by 1 0. It is 0.01. Yes, Sam.
It's like 8:20. That's all.
Oh, okay. I didn't realize the time. So, all right, guys.
Have a good
I will see you guys Monday.